Good afternoon, students. I am Basav sir. Today I am discussing about some important some important figure, that is moment of inertia of some very important figures. Okay. So before I am starting, I am mentioning one point that in previous classes I have discussed two important theorem. According to your syllabus, the proof of the two theorem is not in your syllabus. It's not included in your syllabus. So you have to just actually you have to remember the theorems. But the interested candidate may study the proof, but it is not necessary according to your syllabus. Okay, so you have to just remember the formulas of just theorems, the two theorems or statement of the theorems of the two theorems. Okay, now in today's class, at first I am discussing about the moment of inertia of a rectangle figure. This is rectangle. In your syllabus, there are MI of rectangle, hollow rectangle, square, hollow square, circle, hollow circle, semicircle, and triangle. This 8 type of figure you have to remember. Just formula. In these figures also you have to just remember the formulas, not the derivation. Okay. So at first this is right angle. This is a rectangle, and this is x-axis, and this is y-axis. One point that in my previous two notes, the first note there are some mistakes there in the book, some mistakes in the books. So in the second note I have corrected the mistakes. Today I am discussing about the mistake also. So at first this is rectangle, this is x axis, this is y axis, and this is the length b, this is length b, breadth, this is depth or length, it may be called as length d. So according to formula, the moment of inertia about x-axis, that is ix, will be as b dq by 12, and according to y axis, the Iyy will be dbq by 12. Okay, and according to any other axis, that is an axis AB parallel to x axis, will be as IAB equal to bdq by 12. This is your formula. Now go to the hollow rectangle. Okay, hollow means there in the middle portion there is no material. Similar, this is y, this is o, x axis, and in this case the length are, this is b, this is small b, this is small d, this to this, and this is capital D. So in first formula, in the first note there was the two are the same, bdq and bdq, but in Iyy will be dbq. There was a mistake in first note. Actually this note was from book, and the second note was I have made the note, corrected the things. Now this in this figure, the ix will be as bdq minus b small bdq by 12. Iyy will be equal to dbq minus db small dbq by 12. And according to any other axis, it is not much necessary. Okay, now go to square. For square, you should easily understand that at first for square. In square, the length and breadth will be same, that is, if this is b, then this will be b. So in this formula for square, it will be as b, it will be as bdq by 12, and put b in place of d, then this will be as b into b to the power q by 12, therefore it will be as b to the power 4 by 12. And similarly the iy also will be as or it may be as d to the power 4 by 12. Similarly iy will be b to the power, that is, put d instead of b, that d to the power 4 by 12 or equal to d to the power 4 by 12. Similarly for hollow square, this will be same as in place of b or b we can write d. The if we can take same, this will be same, this b, this will be capital B, so this may be capital B, and this will be, if this will be small b, then this will be also small b, because square all the length will be same. So put b instead of d. So this will be as b into b to the power q minus small b to the power q by 12. This will be actually b to the power 4 minus b to the small b to the 4 by 12. Similarly this will be d to the power 4 minus small d to the power 4 by 12, b to the 4 minus small d to the 4, or it may be as capital B to the power 4 minus small b to the power 4 by 12. So these 4 formulas is discussed. Now I am going to circle. For circle, this is axis and the CG. In these cases, the CG, the x and y axis going through the CG. That is, O is CG in this figure and O is CG in this figure. This is also the x and y axis are going through the CG. So I-axis is going through, I-axis is about CG. Now for this figure, let this is diameter D. This is diameter D. So we may call this is half of this will be radius. Now for square, for solid circle, the formula is pi. That is, in this case Ixx and Iy will be equal, because the circle all the part of the area of the circle is same. So it will be as pi d to the power 4 minus 64. You have remembered this formula. Circle for circle Ixx or Iy equal to pi to the 4 by 64. So okay, now going to hollow circle. Hollow circle is similar type. This part is hollow. X O Y. Now this is D, capital D, and this is small d. And this is small d. So now for this case, the actual formula will be Ixx equal to Iyy equal to pi by 64 capital D to the power 4 minus small d to the power 4. It will be the small d to the power 4. It will be the formula. Okay. So this is the for hollow circle. Now for triangle, any type of triangle. Now triangle, this is this is CG, that is, it may be G, and the x-axis is going through CG. So this is x-axis. Okay. So this is x-axis, and now let this is the height of the triangle, that is this from this to this, from vertex to the base is h, this is h. Now we know from the CG chapter that the height of the CG from the base of the triangle will be 1/3 of the height. Okay, that is, in this case, if this length, if this length is y, that is y coordinate, then y will be equal to h by 3, or y bar maybe as y bar equal to h by 3. So there, actually this length from base to the CG will be as 1/3 of the total height of the triangle. So in this case, the formula will be as BHQ by 36. Okay, according to x, that is Ixx will be as, that is mi about xx axis, and mi about any other axis will be as BHQ by 12. You have to remember it. Any other axis, that is IAB, we may call IAB equal to. And now the last topic is semicircle. For semicircle, let us, the CG is this point, and x axis is going through this point. Okay, so this is y, x, and from the chapter of CG we know that if from base to the if the distance from base to the point of CG is y bar or y, then y bar will be equal to 4r by 3 pi. It is a formula, 4r by 3 pi. So the Ixx will be as 0.11 r to the power 4. If this is r, this part is r, or this is r, that is the radius r. You may take as r. This is r. Then Ixx will be 0.11 r to the 4. Okay. Simply Iyy will be, according to formula, it may be as pi d to the power 4, as this total part is d. Formula is Iy d pi d to the power 4 by 1 to 8. By calculating we can get value of it will be as 0.393 r to the power 4. It is here substituting d equal to r, and then we get this value. And for other axis, that is any other axis parallel to the axis going through CG, that is axis AB, will be as same value pi d to the power 4 by 1 to 8 equal 0.393 r to the power 4. Okay. So how we can get this value? I can explain that. We know that in this case, let this is AB. Okay, so we know that IAB, that is more inertia about any other axis except axis CG, axis going through CG is, we know that IAB equal to IG plus AH square. Okay, so here A is the area of the semicircle, this semicircle. H is the distance from CG to the base, that is from G to AB. So we can get Ig equal to IAB, equating this, or just simplified this. IAB equal to Ig equal to IAB minus AH square. Ig equal to IAB minus AH square. And now putting value of IB value is this. IB value is this. This value is IB, and A is area of the figure is given as we know that the area of a circle will be pi r square. Therefore area of a semicircle will be pi r square by 2. So putting the value here by r square by 2 instead of a, and h equal to as from distance g to base, it will be as 4r by 3 pi this. So putting this value, it will give that 0.11 at the power 4. So these formulas you have to remember. You have not need to study the total derivation of these formulas, but you have to study these formulas and remember these formulas. These formulas are very important. You have to remember for various types of important problem on MI. Okay, that's all. Thank you.